becomes oxidized, it loses electrons. Iron gains those electrons, it gets reduced. It releases a tremendous amount of heat energy. It releases so much heat energy that the iron is molten. It creates molten iron. They actually used to use this to weld iron together. It's kind of easy because it's just finely ground aluminum metal, and this is rust essentially. You mix them together, you have to add a little bit of energy, you have to have like a fuse to start it. Once it starts, right, Trevor? I mean,
I actually have a video on my laptop.
Dude, really?
I recorded that one.
Yeah, once it gets going, it's like poof, and you just get this molten metal that just falls right through the flower pots. It's pretty cool. So this is what they do in our book in chapter 4, real simple redox reactions. You could balance them just by looking at them. You could balance it even if you didn't know it was redox. But more difficult redox reactions, more complicated ones, it gets hard actually to just try to balance them by inspection. Okay? And so what's used is the method that's called half reactions, the method of half reactions to balance these things. And it's actually good to understand and be able to break these things up into an oxidation and a reduction half. And so that's what we're using, the method of half reactions. And I don't know if that's probably not, is that big enough to see? Yeah. Not on there. Sure it's on there. Let's make it a little bigger. Probably not much better, is it? I'm trying to look at the very first one. It's probably not big. I'll rewrite it on the board. Yeah. Okay, so anyways, if you go to Edline, there's this oxidation reduction sheet. Okay, there's 14 reactions in there. One of the quiz questions from the Chapter 4 quiz is coming from this sheet. Okay, guaranteed. So essentially, you're trying to be able to balance these redox reactions. But we're also trying to learn how to do this by the method of half reactions. Okay? So let me just rewrite the reaction up there. It's silver metal. Okay, we've got silver metal. Nitric acid, and then it's going to make silver nitrate. It's going to make some NO2 and water. Nate, do you think I'm writing big enough? Is this...
Yeah, it's just sometimes it's spread out so far that you can't see it.
Okay. We'll do the best we can. I'll try to write the next one a little more complete. Okay, so the first move is go through and assign oxidation states so you know who's being oxidized, who's being reduced.
You just put a 2 in front of the HNO3.
Now, I'm not trying to balance it yet. What I'm trying to do is show you the method of half reactions. In the end, we'll have it balanced, but we're trying to learn the extra parts to this as well. So what do you think the oxidation state is for silver over on the left?
0.
Silver's a 0 on the left. How about over on the right side? It is +1. Would you agree, right? Because nitrate ions are -1. So what's happening to silver? It is being oxidized. Okay, so there's one of the players. Right, what we're trying to do is figure out who the redox players are, who's involved in this. Okay? While silver's being oxidized, somebody's got to be getting reduced. I wonder who that is. Well, could it be the hydrogen? I don't really think so. Hydrogen's a +1 here. Oxygen's a -2. What do you think about in the water molecule? In the water molecule, oxygen would be a -2, and that means the hydrogen is, right, hydrogen's +1. So there's been no change there. Who does that leave? We did this a minute ago. What's the oxidation state of nitrogen in the nitrate ion? It's got to be a +5. How about over in the NO2 molecule? It's a +4. Right, so you see how the nitrogen's been reduced because its oxidation state's gone down. So we figured out who the players are. So what the idea now is to split this thing up into what are known as half reactions. There's an oxidation half and a reduction half.
Why do we ignore the nitrogen?
Well, this nitrogen has not changed. Right, this one, there's a nitrogen here that's a +5. There's still a nitrate ion here, so this one's still a +5, but this nitrogen is dropped. That's one that's actually being reduced. So I'm going to split this thing up into an oxidation and reduction half reactions. Okay, so for an oxidation, again, that was our silver. Okay, so on the left side, right, it was just silver metal. And you know how silver nitrate is aqueous, right? It even says it in the equation, and we know all nitrates are soluble. So I'm just going to use the silver ion over on the left. If something's aqueous, think of it as ions. If it's ionic, it's going to be ions. Right, when I do the half reaction, I'm just picking out who the players are. And I'll do the same thing for reduction. Okay? So I know it's the nitrogen in the nitrate ion that's being reduced. You cannot just pick the nitrogen atom out of there, though. The nitrate ion's a unit. Okay, you can't just write nitrogen by itself. I'll have to write nitrogen in the nitrate ion. And on the right side, I'll have NO2. Okay, so we isolated who the players are. Who's getting oxidized, who's getting reduced. And then to balance the half reactions, you go through the same little 4-step routine every single time. We're going to try to create balanced half reactions. All right? So here's the routine. You balance any element that's not hydrogen and oxygen. If it's not hydrogen and oxygen, balance it first. Well, there's one silver on the left and on the right side. The silver's good. The nitrogen's okay as well. One nitrogen, one nitrogen. So phase one's complete for both of the half reactions. Second step, you use water molecules to balance out oxygen atoms. Use water molecules to balance oxygen. Well, the top reaction doesn't even have oxygen in it, so no worries. But down here, we're going to have to use some water molecules. I see 3 oxygens on the left, 2 oxygens on the right. What do you think we ought to do? Add a water molecule to the right side. Right, because then that'll balance out the oxygens. Step number 3. we're going to use hydrogen ions to balance out hydrogen. Now, most redox reactions that are aqueous happen in either an acid or a base environment. And so you always assume it's acid to start with. We'll worry about a base solution later. Okay? So use hydrogen to balance hydrogen. Hydrogen ions to balance hydrogen. No hydrogen in the top reaction, but down here we do. So we got 2 hydrogen atoms on the right, so guess what we'll have to add to the left side? 2 hydrogen ions. Okay, phase 3 complete. The fourth move is use electrons to balance the charge. You have to have the same overall charge on both sides of the arrow. Use electrons to accomplish that. So in the top reaction, the total charge on the left is 0. It's +1 on the right. So what do you think we should do there? We're going to add 1 electron over to the right side, because then the negative and the positive will cancel. We'll have 0 charge on both sides. Now, we're not saying you have to have 0 all the time as the charge, but you're just trying to get the charge the same on both sides. What do you think about the bottom one? There's no charge on the right at the moment. The left-hand side, what does that add up to? You see how this adds up to a +1, right? So +1 on the left, no charge on the right. I'm thinking we're going to have to add an electron here so that I have no charge on both sides. So phase 4, add electrons so you can get the charges to balance. Seem good? So now the halves are balanced. The next thing we're going to do is add up the halves to get the balanced net ionic equation. The method of half reactions will get you the balanced net ionic equation. Now, before you add up the halves, you have to get the electrons to cancel out, because you have to have the same amount of electrons gained as there are lost. Well, this one's really easy because we're gaining and losing 1 electron, so they balance out naturally. You should be able to cancel out the electrons in the adding process. If they didn't, like let's just say for a second, let's say this was a 2 here, right? Let's say there was a 2 electrons here, then we'd have to double the top reaction so we could get 2 electrons to cancel out for each one. So I'm just going to add it up. So we've got 1 silver. We're going to have 2 hydrogen ions. We've got a nitrate ion. And then we'll have silver ions on the right side. We have an NO2 molecule. And we have an H2O molecule. I like to pick number 1 to start with because it's easy. All right, there's nothing fancy or tricky there. Feel okay with this? Now we'd have one last task. If we're trying to balance the original reaction, we just have to realize that there could be some spectator ions up here that we don't have down here. So we just have to use this, the balanced net ionic, to help us up here. Some of it's easy, like I see 1 silver atom. This is going to be a 1. I try to match up the easy stuff first. Okay, I see a silver ion here. There's a silver ion there. This must be a